Okay. Algebraic expressions. Simplify 2x cubed all to the 4 divided by 4x to the 5. 2x cubed all to the 4 is 16x to the 12. 16x to the 12 divided by 4x to the 5 is 4x to the 7. So 4x to the 7 is 2x cubed all to the 4 divided by 4x to the 5. Evaluate 8 over 27 all to the negative 2/3. 8 over 27 to the 1/3 is 2 over 3. To the 2/3 is 4 over 9. To the negative 2/3 is 9 over 4. So 9 over 4 is the evaluation of 8 over 27 all to the negative 2/3. Express 8 to the 2/3 divided by root 2 as a single power of 2. Eight to the 2/3 is 4. Which is 2 to the 2. 2 to the 2 divided by 2 to the half is 2 to the 3 over 2. So 2 to the 3 over 2 is 8 to the 2/3 divided by root 2 expressed as a single power of 2. Hello. Okay. That's really hard. Express 2x take 3 times x plus 4, all take 2x times x take 1. 2x 2x take 3 times x plus 4 is 2x squared add 5x, take 12. Now take 2x squared. First term cancels, so we're left with 5x, take 12. Now add 2x, so we're left with 7x, take 12. So 7x take 12 is 2x take 3 times x add 4, all take 2x times x take 1. Factorize fully 4x cubed take 25x in the form x times ax take b times ax plus b. We factor out x to get 4x squared take 25. We apply the difference of two squares, so it's x times 2x take 5 times 2x add 5. So x times 2x take 5 times 2x add 5 is 4x cubed take 25x in the form x times ax take b times ax add b. Express 3 root 8 take root 50 plus root 18 as a single surd. Three root 8 is 6 root 2. Negative root 50 is negative 5 root 2. Root 18 is 3 root 2. Their sum is 4 root 2. So 4 root 2 is 3 root 8 take root 50 plus root 18 expressed as a single surd. Express 2 root 5 take 3 all squared in the form a plus b root 5. Squaring, we get 29 for the constant, 29 for a, and then negative 12 root 5. Thus, 29 take 12 root 5. So 29 take 12 root 5 is 2 root 5 take 3, all squared, expressed in the form a plus b root 5. Yeah. Write 8 over 3 plus root 5 in the form a plus b root 5. Rationalize the denominator. Multiply top and bottom by 3, take root 5. The denominator becomes 4. The numerator becomes 24, take 8 root 5. So 6, take 2 root 5. So 6, take 2 root 5 is 8 over 3 plus root 5 in the form a plus b root 5. Alright, that's chapter 1. Now the chapter 2. Okay. Solve 2x squared equals 5x at 3. Rearrange. 2x squared take 5x take 3 equals 0. Factorize. 2x at 1 times x at take 3 equals 0. Solve. X is negative a half or 3. So x is negative a half or 3. For 2x squared equals 5x, add 3. Express 2x squared at 8x at 3 in the form a times x at b all squared plus c. Two times x at 2 all squared, take 5. So 2 times x at 2 all squared, take 5 is 2x squared at 8x at 3 in the form a times x at b all squared plus c. State the turning point of y equals 3, take 4x, take x squared. We use the line of symmetry. which is minus b over 2a. So in this case, minus minus 4 over minus 4 over minus 2, which is negative 2. So sub x equals negative 2 into 3 minus 4x minus x squared. Which is 3 plus 8 minus 4, which is 7. So negative 2, 7. So negative 2, 7 is the turning point of y equals 3, take 4x, take x squared. Solve x squared, take 4x, add 1 equals 0 in the form a plus or minus root b. Okay, apply the QF. Find discriminant first. (16 minus 4 is root 12). 16 minus 4 is 12, so it'd be root 12 on that part. 4 plus or minus root 12 all over 2. 4 plus or minus 2 root 3 all over 2. 2 plus or minus root 3. So 2 plus or minus root 3 solves x squared minus 4x plus 1 equals 0 in the form a plus or minus root b. Hello. State the number of real roots of 2x squared minus 5x plus 4 equals 0. Use the discriminant, which is b squared minus 4ac. So 25 minus 4 times 2 times 4. 25 minus 32 is negative 7, that's negative, and thus it has no real roots. So there are no real roots for 2x squared take 5x at 4 equals 0. Or was that a y? Cool. Find the values of k for which x squared at kx at 9 equals 0 has equal roots. Plus or minus 3. Plus or minus 3 are the values of k for which x squared at kx at 9 equals 0 has equal roots. A ball's height, h, is modeled by h equals 30t, take t squared, find its greatest height. We find its roots. Zero equals 5t, open brackets, 6 take t. The roots are 0 and 6. At t equals 3, the height would be maximum. "30 times 3, take 5 times 3 squared. "90 take 45, 45. After 3 seconds, the ball reaches its maximum height of 45 meters when the height is modeled by h equals 30t, take 5t squared. We're assuming t is in seconds. Okay. Okay. Solve 2x at 3y equals 4 and 3x take y equals 17. The second equation, y is equal to 3x take 17. Oh no. Okay. Solve 2x at 3y equals 4 and 3x take y equals 17. For the second equation, y is equal to 3x take 17. Pick that up, put it in the first. "2x at 4, 2x at 3 times 2x at 3 times 3x take 17. So 2x at 9x take 51. So 11x take 51. 11x take 51 equals 4. So 11x equals 55. So x equals 5. And if x is 5, then 10 add 3y equals 4. So 3y equals negative 6. So y is equal to negative 2. So x equals 5 and y equals negative 2 when 2x at 3y equals 4 and 3x take y equals 17. Hello. Solve y equals x take 1 and x squared add y squared equals 25. Substitute y for x take 1 in the second equation. So x squared plus the square of x take 1 equals 25. So 2x squared take 2x. 2x squared take 2x plus 1 equals 25. Two x squared take 2x take 24 equals 0. So x squared take x take 12 equals 0. So x take 4 times x add 3 equals 0. So x equals 4 or 3. No, wrong. X take 4 times x add 3 equals 0. So x equals 4 or negative 3. And if x is 4 or negative 3, then y is 3 or negative 4 respectively. So 4, 3 and negative 3, negative 4 solve y equals x take 1 and x squared add y squared equals 25. How many points does y equals 4x take 1 share with y equals x squared add 3? Equate 4x take 1 equals x squared add 3. X squared take 4x add 4 equals 0. Discriminant the discriminant is 0 and thus exactly one solution. So y equals 4x take 1 and y equals x squared add 3 have exactly one solution. Solve 3 brackets x take 2 is greater than or equal to 5x at 4. Expand on the left. 3x take 6 is greater than or equal to 5x at 4. Minus 6 is greater than or equal to 2x at 4. Minus 10 is greater than or equal to 2x. Minus 5 is greater than or equal to x. So x is less than or equal to negative 5. So x is less than or equal to negative 5 solves 3 brackets x take 1 is greater than or equal to 5x at 4. Hello. Solve x squared is greater than or equal to 3x at 10. Move it to the left. X squared take 3x take 10 is greater than or equal to 0. Solve like an equation. X take 5 times x at 2. The roots being -2 and 5. And thus x has to be less than or equal to -2, or x has to be greater than or equal to 5. What was the original? Alright, the original is lost. Solve x squared is greater than or equal to 3x at 10. Move it all to the left. X squared take 3x take 10 is greater than or equal to 0. Solve like an equation. So by factoring, x take 5 times x at 2, and thus we get -2 and 5, and so x is less than or equal to -2, or x is greater than or equal to 5. So x is less than or equal to -2, or x is greater than or equal to 5. Solves x squared is greater than or equal to 3x at 10. For which x is the curve y equals x squared below the line y equals x at 6? Solve for x simultaneously. X squared equals x at 6, so x takes 6, x squared take x take 6 is equal to 0. So x take 3 times x at 2 is equal to 0. Solutions 3 and -2. And thus, for x between 3 and -2 inclusive, for x between 3 and -2 inclusive, y equals x squared is under the line y equals x at 6. How many of the points 1, 2, 3, 1, and 0, 4 satisfy both of y is less than or equal to 4 take x and y is greater than x take 2? We try the first point, which is 1, 2. And does it satisfy that y is less than or equal to 4 minus x? Yes. And does it satisfy y is greater than x minus 2? Yes. So 1, 2 passes. Now we try 3, 1. For the first relation, y is greater than or equal to 4 minus x. Correct. For the second relation, y is less than x minus 2. No, y is greater than x minus 2. Fails. The second point fails. We try the last point, 0, 4. For the first relation, y is less than or equal to 4 minus x. Valid. For the second relation, y is greater than x minus 2. Valid. Okay, so it only works for 2 points both. And those points were 1, 2 and 0, 4. Hello. Okay, chapter 4. Graphs and transformations. Okay. State the y-intercept of y equals 2 times x add 3 times x take 1 times 2 take x. We multiply the constants and thus 3 times 1 times 2, 3 times 1 times 2, and then times 2 again. No, wrong. 3 times -1. Okay, we have to try again. State the y-intercept of y equals 2 times x add 3 times x take 1 times 2 take x. Multiply the constants, so 3 times negative 1 times 2, and then times 2 again, so negative 12. Multiplying the constants is another way for me to say setting x equal to 0. So negative 12 is the y-intercept of y equals 2 times x add 3 times x take 1 times 2 take x. How many points does y equals x squared times x squared take 9 share with the x-axis? Okay. So that's a degree 4 polynomial. And therefore it's a W shape. Well, I mean, sort of like a W shape. But let me just say this. Y equals x squared times x squared take 9 can be factorized into y equals x squared times x add 3 times x take 3. And so it crosses at negative 3, positive 3. Rather, it intercepts at negative 3, 0, and positive 3. Do you mean sharing? Do you mean tangential or what? No, you don't. You don't mean that. Okay, I know what your shape is. I see you. 3. 3 times. So it is 3 times that y equals x squared times x squared take 9 touches the x-axis, crosses the x-axis. Right. How many points do y equals 1 over x and y equals 1 over x squared share? Set them equal to each other, so 1 over x equals 1 over x squared. No, your shape is different. You shouldn't have more than 1 point in common, should you? And it shouldn't be anything other than 1. You should share 1 point. That's what I think. I think you have 1 point in common. Y equals 1 over x and y equals 1 over x squared. How many points do y equals x cubed and y equals 4x share? Equate. X cubed equals 4x. So x cubed take 4x equals 0. So x times x squared take 4 equals 0. So x times x add 2 times x take 2 equals 0. So x is negative 2 or 0 or 2. And thus they share 3. Three points are shared by the curve y equals x cubed and the line y equals 4x. The minimum of y equals f of x is 2, negative 5. Find the minimum of y equals f of x at 3. Adding 3 to the argument translates all points by 3 units to the left. And so 2, negative 5 becomes negative 1, negative 5. So negative 1, negative 5 is the minimum of y equals f of x at 3 when f of x equals, when the minimum of y equals f of x is 2, 5. 2, negative 5. That's what it says. That's what it says. Mentally. F of x equals 0 only at x equals 4 and x equals negative 6. Solve f of 2x equals 0. Okay, multiplying the argument by 2 compresses the graph by a factor of 2, as in squashes it like this by a factor of 2. And if the zeros occur at 4 and 6, then they now at 4 and negative 6, then they now occur at 2 and negative 3. So 2 and negative 3 are the solutions to f of 2x equals 0 for the function f of x, which is only 0 when x is equal to 4 or negative 6. Hello. Three, negative 2 lies on the curve f of x. State its image on 2 times f of x at 1. Okay. Multiplying the whole function by 2 has the effect of multiplying the y coordinates by 2. And adding 1 to the whole function has the effects of adding 1 to every y coordinate. So 3, negative 2 under the first transformation becomes 3, negative 4, and then under the second becomes 3, negative 3. So 3, negative 3 is the image of 3, negative 2 under the function transformation to f of x plus 1. Okay, that was great. Hello. Okay, so only one error. Question 14. Oh my goodness me. That's so obvious. I was thinking of the factorized form. Okay. Of course. Right. So what now? Right, so I have to look at this. Alright, well, let's pause it there actually. Thank you.